All right, we got 3 regular 6-sided dice tossed at the same time. So what's the probability of getting a sum less than or equal to 16? Okay, so I could get, I guess the smallest I could get would be 3 1. So I could get a 3 up to, let's see, if I get all 6s, it would be up to 18. So really, I only need, let's see, less than or equal to, I need like, oh gosh, there's so many to do that way. I think if I just do 1 minus the probability of 17 plus the probability of 18, that'll probably make it out to be the right size. So I need to figure out the 17 and the 18 and then subtract it, and that'll give me everything else. Okay, so let's see here. To do that, I could get, let's see, how could I get 17 out of it? Let's just do this the very old-fashioned way. I could get 6, 6, 6, and that gives me an 18. Okay, so I could also get, let's see, I guess to get a 17, a 6, 6, 5, is that right? Let's see, that's 12, that's a 17. But I could get, that's 3 ways to do it, right? Because I could get the 5 first, second, or third. I think that's everything. Okay, so that's much smaller than I thought it would be. So I need 1 minus, because it's 100% minus 4 ways out of, let's see, there's 6-sided dice, so it's 6 times 6 times 6 is 216. All right, so simplifying that, that's 216 over 216, oops, minus 4 over 216. That gives me just 212 over 216. Yeah, and I can leave it like that, I think. All right, that's not nearly as bad as I thought it was going to be. During 3 days in November, the probability of rain in Tacoma is 70% each day. Make a probability distribution table for R in the number of days receiving rain. Okay, I don't need to compute each number. Okay, so this is like a probability distribution table, and I can use I can use this one here where it's the probability times, let's see, it's, I guess the probability of success to the x times the probability of failure. That's the formula I need to use. I just really need to set that up for each one of those. It's 3 days, so I guess, so the probability of rain, let's see, I could get 0 days of rain, 1 day of rain, 2 days of rain, or 3 days of rain. Okay, so to do each one, you know what, I'm just going to build these real fast, and you can examine the answers. All right, that should give me everything. Notice that the exponents add up to be 3 because it's the total number of days. And the inside, like the successes and the failures, add up to be 1. Find the expected value and the standard deviation on the number of rainy days. This is actually, this is the shortcut right here. It's going to be mu is NP, and this is going to be standard deviation is the square root of NPQ, which means I can just fill these values in. Let's see. So let's see. Mu is going to be, let's see, N is that 3 days, and the probability is 70%. So we're gonna get 2.1 out of that, and then this, for the standard deviation, we're going to get the square root of 3 times 0.7 times, see, Q is going to be, just adds up to 1, so 0.3. I get something like the square root of 0.63, which is approximately 0.7937. Okay. So expected value and standard deviation, so 2.1 and 0.793, 2 decimal places.